Physics 2-9 free fall acceleration section of the notes. Um, the picture you see here is a feather and an apple falling in an evacuated chamber. It's a vacuum, so there's no air resistance, so the feather and the apple will fall exactly at the same rate. If there was air resistance, of course, that wouldn't be the case. But free fall acceleration is the acceleration of -10 meters per second squared. So all objects near the surface of the Earth will accelerate at that value if there is no air resistance. And that's what we look at first, no air resistance. It says here a feather and an apple free fall in vacuum at the same magnitude of acceleration g. The acceleration increases the distance between successive images in the absence of air. The feather and apple fall together. We're going to look at an example of an astronaut on the moon dropping a feather and a hammer. It's a YouTube video.
Well, in my left hand I have a feather. In my right hand a hammer. I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully it'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
There's 3 points of discussion here. First point, the directions of motion are now along a vertical y-axis with a positive direction of y upwards. The free fall acceleration is negative, that is downwards in the y-axis towards the Earth's center, and so it has a value of -g. G is 9.8 meters per second squared. Negative g is -9.8 meters per second squared. The free fall acceleration near the Earth's surface is a equals -g, which equals -9.8 meters per second squared. And the magnitude of the acceleration is 9.8 meters per second squared. Do not substitute -9.8 for g. In future physics problems, whenever you see a g, you always plug in 9.8. We're going to do a sample problem here. On September 26, 1993, Dave Munday went over the Canadian edge of Niagara Falls in a steel ball equipped with an air hole, and then fell 48 meters to the water and rocks. Assume his initial velocity was 0, and neglect the effect of the air on the ball during the fall. How long did Munday fall to reach the water surface? So what I want you to do is go back, and actually I'll just go back here, and go back, and we're going to write down all our givens. I want you to, on a separate sheet of paper, write down the givens you see here. Pause the video right now, write down the givens, and then go to the next clip here, and go ahead and solve the problem. Okay, so you should have the following givens. The initial velocity is 0, the delta y is -48 meters, the acceleration is -9.8 meters per second squared, the change at time is what you need to solve for. We hopefully decide what equation to use here, and here's how it works out. Use the delta y equals v ot plus 1/2 at squared, and they plugged in -9.8 for your acceleration, and you come up with a time of 3.1 seconds. Then it says, Munday could count off the 3 seconds of free fall, but could not see how far he had fallen with each count. Determine his position at each full second. So again, pause the video, see how far he has fallen at each second. One thing to remember is this isn't for just this problem. Anything in free fall after 1 second will fall a certain distance, after 2 seconds will fall a certain distance, after 3 seconds will fall a certain distance. This is the same for all of these problems near the surface of the Earth. So here is your answer. After 1 second, you go -4.9 meters. After 2 seconds, -19.6. After 3 seconds, -44.1. If you use 10 as your acceleration, then it'll be 5 to -45. So here's the chart. Write this in your notes. And then last thing, what was Munday's velocity as he reached the water surface? Again, pause the video, come come up with the answer. It's negative 31 meters per second, which is about 110 kilometers per hour. The next example is a rock is shot vertically upwards from the top of a tall building. The rock reaches its maximum height above the top of the building 1.6 seconds after being shot. Then after barely missing the edge of the building as it falls downwards, the rock strikes the ground 6 seconds after it is launched. In SI units, what upward velocity is the rock shot? B says what maximum height above the top of the building is reached by the rock? And C, how tall is the building? So pause the video, see if you can solve these problems. Write down your givens. So for part A, you should end up with an initial velocity of 15.7 meters per second. For part B, you should have ended up with an answer of 12.5 meters for the highest point. And for part C, you should have 82.3 meters as being your height of the building. So look at the explanations here and see if they match what you have. If you have any questions on any of this, please come see me. Discuss it.